If negative 3 comma negative 6 is a point on the terminal side of an angle, what is the reference angle in radians, and what is the smallest possible positive angle containing the point? Let's begin by plotting the point. And now sketch the smallest possible positive angle in standard position. The initial side is along the positive x-axis. Rotating counterclockwise, the terminal side would pass through the given point. This is the smallest possible positive angle passing through the given point. From here, let's sketch the reference triangle. To do this, we sketch a perpendicular segment from the point to the negative x-axis. This right triangle formed is the reference triangle, and the reference angle is the angle between the negative x-axis and the terminal side. Let's label the reference angle angle theta. Because x equals negative 3, we can label the adjacent side to angle theta negative 3. Because y is equal to negative 6, we can label the opposite side to angle theta negative 6. Let's sketch this reference triangle larger on the right. Now, if we were determining the trig function values for the given angle, we would need to use a negative 3 for x and a negative 6 for y. But because we know the angle theta is an acute angle, or between 0 and pi over 2 radians, we can take the absolute value of negative 3 and the absolute value of negative 6 and label the two legs 3 and 6 to determine the measure of the reference angle angle theta. On the coordinate plane, tangent theta is equal to y divided by x, or using the right triangle, tangent theta is equal to the ratio of the opposite side to the adjacent side, and therefore tangent theta is equal to 6 divided by 3, which is equal to 2, which means theta is equal to inverse tangent of 2. So again, when determining the reference angle, we can use positive values for both x and y, or positive values for the legs of the reference triangle. But that would not be the case if we were trying to determine the trig function values of the angle passing through the given point. So going to the calculator, inverse tangent of 2 to 4 decimal places is 1.1071. Let's go ahead and record this above. Let's also record this on the coordinate plane. We now know angle theta is approximately 1.1071 radians. And that's because the smallest possible positive angle terminates in the third quadrant. If we call the angle we're looking for angle A must be equal to pi plus 1.1071 radians. Going back to the calculator, angle A is approximately 4.2487 radians, which is the smallest possible positive angle containing the given point. I hope you found this helpful.